guys, how are you guys? I hope not peel. So in today's video we are supposed to be covering what the quadratic sequence. We have already dealt with the arithmetic sequence, we have already dealt with the geometric sequence. We said an arithmetic sequence is a sequence in which the difference between any two successive terms is some constant d, right? Here in quadratic sequences we are talking about what the second difference. So a full definition of a quadratic sequences goes as: a quadratic sequence is a sequence of numbers of which the second difference between successive terms is a constant value. So in the arithmetic we were talking about the first difference. So when you say t2 minus t1, you get the difference for the term. That was your first difference. So in the quadratic we are talking about what the second difference. So we have to first find the first difference and then go find the second difference, and the second difference will give us what? A constant. So I have already prepared two sequences so that we try to see how a quadratic sequence should be like. So let's consider the first sequence where our term number 1 or first term is 4, second term 7, third term 12, and 19, 28, right? So to find the difference between two terms, let's begin with the first one, t2 minus t1. So t2 minus t1 is more like it's 7 minus 4. So this will give us 3. And then second is t3 minus t2, 12 minus 7. This will give us 5. And then we go 19 minus 12. This will give us 7. 28 minus 19. This will give us 19. So this is our first difference of the given sequence, and we can see that it does not give us what? A constant value. Therefore we are not talking of what? A quadratic sequence. So we go on to look at what? Try to find the second difference of the sequence. So 5 minus 3 gives us what? 2. 7 minus 5 also gives us what? 2. 9 minus 7 gives us 2. So the second difference of this sequence is the one that gives us what? A constant value of 2. So therefore we conclude that this is what? A quadratic sequence, since the first difference did not give us a constant value. Let's look at the second sequence. So the second sequence, we have 8, 17, 32, 53, and 80, right? We do as we did before, we find the first difference. So here we have 17, it's going to be 17 minus 8. So this one will give us a 9, and then we follow, we get 15, we get 21, we get 27, right? Again, we did not get what? A constant value in the first difference of the sequence. So we go on again and try to find what? The second difference of the sequence. So 15 minus 9 gives us a 6. 21 minus 15 gives us a 6. 27 minus 21 gives us what? A 6. Since the second difference gives us a constant again, this is what? A quadratic. We conclude that this is a quadratic sequence. Also this one is a quadratic sequence. So if the first difference is not a constant value, but the second difference is the constant value, we are dealing with what? A quadratic sequence. So let's go on and try our questions in another quadratic sequence. Aware? So we have already established what a quadratic sequence is and how it differs from a arithmetic sequence. So let's look at this question. It reads as follows: determine whether each of the following sequences is a linear or a quadratic sequence. So we have to look at what the differences of the sequence, right? So we look at the first difference and the second difference. If the first difference is the one that is giving us a constant value, therefore arithmetic. If the second difference is the one that is giving us a constant, therefore quadratic, right? So let's look at A. So in A we have a sequence that is composed of numbers 7, 9, 13, 19, and 21, right? So we have to look at the first difference of this sequence. So the first difference, 9 minus 7, we get a 2. 13 minus 9, we get 4. 19 minus 13, we get 6. 27 minus 19, we get 8. So the first difference did not give us what? A constant value. So we go on and look at what, or try to find the second difference of the sequence. So again, so 4 minus 2, 2. 6 minus 4, 2. 8 minus 2, 2. So the second difference of the sequence gave us what? A constant value. So therefore we can conclude that this sequence is a quadratic sequence. Let's look at B. B is composed of 3p squared, 6p squared, kanjalo kanjalo to 15p squared, right? We do as we did before. Let's first look at the first difference of the sequence. So first difference, we start by saying 6p squared minus 3p squared, we get what? 3p squared. 9p squared minus 6p squared, we get 3p squared. 12p squared minus 9p squared, we get again 3p squared. And then 15p squared minus 12p squared gives us again what? 3p squared. This is our first difference. So since the first difference gives us a constant value, there is no need for us to go and find the second difference. We can just conclude here that this is not a quadratic sequence. It is what? An arithmetic sequence, or rather a linear sequence. Easy as that. This is how you can determine whether a sequence is quadratic or not, right? So now we have to go and look at what the general term of what a quadratic sequence. Since we are dealing with what a quadratic sequence, from quadratic equations, the general term of a quadratic sequence is given by Tn equals to an squared plus bn plus c, right? So in the next part of this video, we're going to be determining how, or trying to find a way on how we can determine the values of a, b, and c. So let's do that. In the last part of this video, I said the general term of the quadratic equation is given by this formula, right? We can determine the values of a, b, and c for each given quadratic sequence so that we can find any term in the quadratic sequence, right? So let's first find four expressions, or four algebraic expressions of what? Of the quadratic sequence, right? What do I mean by that? Let's find T1, T2, T3, and T4 of the quadratic sequence, right? So for T1, remember we know that n is equals to 1. So wherever there is n, we'll substitute 1 in the general term of the quadratic equation. So we have T1 being equals to a 1 squared plus b multiplied by 1 plus c, right? So this simplifies to, therefore T1 is equals to a plus b plus c. So this is the first term. And then we find the second one. So T2 would be equals to a multiplied by 2 squared plus b multiplied by 2 plus c. Therefore T2 would be 4a plus 2b plus c. This will be our second term. Third one, T3 equals to a multiplied by 3 squared plus b multiplied by 3 plus c. This is equals to 9a plus 3b plus c. This will be our third term expression. And then we go to the fourth one. So we have T4 equals to a multiplied by 4 squared plus b multiplied by 4 plus c. Therefore T4 would be equals to 16a plus 4b plus c. This will be our fourth term expression of a quadratic sequence. So what we do now is put them in a sequence. So the first term would be, so let me do this. So the first term would be this one. So we would have A plus B plus C. Next term, term number 2, 4A plus 2B plus C. Third term, 9A plus 3B plus C. The last term, which is the fourth one, 16A plus 4B plus C, right? And then we do as we did like in the previous example, we go and find the first difference of the sequence. So let's do that. Wow. So the first difference here would be, this is term number 1, term number 2, term number 3, and the fourth term. So it will be T2 minus T1. So that's going to be 4A plus 2B plus C minus A plus B plus C. So here we would be having what? 3A plus B. T3 minus T2. That's 9 minus 4A. So this would give us 5A plus 3B minus 2B plus B. C minus C, 0. T4 minus T3. So 16 minus 9A. This one would give us 5A. Sorry, not 5A. This would give us 7A plus B, right? And then we go and find what? The second difference of the sequence. So this would be 5A plus B minus 3A plus B. This would give us 2A. 7A plus B minus 5A plus B. This will give us what? 2A. As expected, we found that the second difference is a constant value. So we will be using this to find the values of A, B, and C, so that we substitute in the general term of the quadratic equation. So in the next part of this video, I'm going to be showing you how we can use this to find the value of the given the values of A, B, C for a given quadratic sequence. So in the last part of this video, we showed this or derived this from the general term of our quadratic sequence, right? So we're going to use it to find the values of A, B, and C, so that we can find any term in any given quadratic sequence, right? So what are we going to use here? I'm going to be using the second difference to find my value of A. After finding the value of A, I'm going to substitute it in the first difference of the first successive terms of the sequence and find the value of B. And then after that, I go to the first term of the sequence, substitute A and B to find C, right? So let's do that. So remember, if I use the second difference in this derived part of the equation, I must also use the second difference in a given sequence. So I'm going to have 2A, second difference, equals to 2 in the second difference of the given sequence. So to find the value of A, I would have what? 2A should be equals to 2. So therefore, A is equals to 1. I go to the first difference between the first successive terms. It's 3 multiplied by A plus B. So I already have the value of A. This should be equals to 3. So I have 3A plus B equals to 3. 3 multiplied by 1, because the value of A is calculated as 1, plus B equals to 3. Then I transpose this, value of B is equals to 0, right? I have the value of A and B now. I'm going to substitute those two values where in the first term of the sequence. So A plus B plus C should be equals to 4. So I have A plus B plus C equals to 4. I have the value of A, it's equals to 1. The value of B, 0, plus C. This is equals to 4. So I need to solve for C. I transpose the 1. Therefore, my C is equals to 3. Right? I take all of these values, I substitute in the general equation of the quadratic sequence. So I have Tn equals to, what's the a value? 1 multiplied by n squared plus 0 multiplied by n plus 3. Therefore, the general term of this given quadratic sequence is n squared plus 3. So to be sure if the general term is correct for a given sequence, you can check it by trying to find the terms in the sequence. So the first one, if this is t1, this will be 1, so 1 plus 3 will give us 4. So you can check for all of the terms. So yeah, this is how you would find the values of a, b, and c in any sequence. Okay, so what's left now for us is to just do questions, right? So I know that you have done this grade 11, so this is just me repeating, making sure which I cover all of the sequences will be in the videos that I do. So I think we'll do 2 questions because questions mostly are easier, right? So let's look at this one on the board. A quadratic pattern is given by Tn is equals to n squared plus bn plus c. Find the values of b and c if the sequence is -1, 2, 7, and 14. So therefore the sequence continues, right? So we know that this is our T1, T2, T3, T4. And we are told that this is a quadratic sequence, right? So we know that we are expecting to find the second difference as a constant. So T2 minus T1, that's 2 minus 1. So this would give us 3. And then 7 minus 2, this will give me a 5. 14 minus 7, this will give me a 7. And then we go find the second difference. So this is 2, 2, right? Why am I doing this? Remember that the general term of a quadratic sequence is Tn is equals to an squared plus bn plus c, right? And they have given us the general term Tn as n squared plus bn plus c. So already they have found the value of a. So the value of a here is what? Is 1. And also if you can find it for yourself, you can see because you use 2a equals to 2, therefore a is equals to 1. So what's left for us is to find b and c. So since we have the value of a, we know that we have 3a plus b should be equals to 3. So that's the first difference of the first successive terms. So we already have the value of a, so we have 3 multiplied by 1 plus b equals to 3. Therefore, again, b is equals to 0. So I know this may seem like b should always be equals to 0 because, again, in the last example we did, b was 0. That's not always the case, but if you just do your math, eventually you will get the right values of b. But in this case, b is equals to 0. So we have already calculated what? Our b value. So we have to go now calculate what? The c value. Again, we know that we have a plus b plus c. This should be equals to the first term of the sequence, and the first term of the sequence is -1. The a value is 1, b 0 plus c equals to -1. Therefore c should be equals to -1 minus 1. So c is equals to -2. Done. You have already answered the question. First term of a quadratic sequence is 4, right? So they're giving us term number 1. This is 4. It continues and says the third term is 34. So T3 is equals to 34. And then it continues again and says the common second difference is 10. So this is equals to 10. Determine the first 6 terms in the sequence. So they need us to determine first 6 terms of the sequence. So the best way or easier way I would say to do is to first find the general term of this sequence, then we can find what our 6 terms. Sharp. So how are we going to find the general term of the quadratic sequence? So we are given 2 terms, just like before, arithmetic, number geometric. If you are given 2 terms, you can generate 2 equations, right? So we have T1 and T4. We already know that the general term of the quadratic sequence is given as Tn an squared plus bn plus c, right? So for T1 we know that everything should be, the n value is equals to 1. So T1 is equals to a1 squared plus b multiplied by 1 plus c. We know that T1 is equals to 4, so it's 4 equals to a plus b plus c, right? So we have this equation, so I can call it equation 1. And then we go again and use in the third term that we are given. So again we substitute in this general equation. So for T3 we have a multiplied by 3 squared plus b multiplied by 3 plus c, right? We know that T3 is equals to 34, so this will be 34 equals to 9a plus 3b plus c, equation 2. But now the problem here is that we have 3 unknowns. We have a, b, c as our unknowns, but again we should not forget that we are given what the second difference of the sequence, and there we know that we can find the value of a. So since this is the second difference, we know that 2a should be equals to 10. Therefore a is equals to 5, right? So in both equations we have what? The value of a. So this equation I can write it as 4 equals to 5 plus b plus c. Sharp. So let me make one of the 2 variables a subject of the formula. So I'm going to transpose this 5 this side. So I'm going to have 4 minus 5. This will give me minus 1. Transpose b again, so I'll have minus b. This is equals to c. So let me not call this equation 1. Start the pants. This is my equation 1. Also this one. So again, I have what? The value of a. So I'll have what? 4 equals to 9 multiplied by 5 plus 3b plus c. Where's my calculator? So 9 times 5 should give me 45. So I have 34 equals to 45 plus 3b plus c. Transpose. So I'll have 34 minus 45. This will give me minus 11 equals to 3b plus c. Then this will be my equation 2. So I'll sub equation 1 into equation 2. Equation 2. So I have negative 11 equals to 3b minus 1 minus b. So I have minus 11 plus 10 plus 1 equals to 3b minus b. Therefore I have minus 10 equals to 2b. So b will be equals to minus 5. Sharp. So I also have what? The value of b now. This is the value of a. How do I find c? I take this b value, I substitute into equation 1. So what I'll be having is minus 1 minus 5. This is equals to c. So this is negative 1 plus 5 equals to c. Therefore c value is equals to 4. So our general equation for the quadratic sequence is Tn is equals to 5n squared minus 5n plus 4. So since now that we have the general equation, we can find what? The first 6 terms that they are looking for. So they are looking for T1, T2, T3, T4, T5, and term number 6. So what we're going to do for term 1, where there is n, we substitute 1. And then we're going to get what? The term that they are looking for. For term number 2, for n, we're going to substitute what? 2. Kanjalo for all of them. So, like calculating. So you can also do it on your own there. So 5(1) squared minus 5(1) plus 4. So the first term of the sequence is 4. We go find the second term. 14. Third term. 34. Okay, I'm going to say guys. So you will continue up until you get how many terms? 6 terms. So what you need to do for term number 1, where there is n in the general equation, ufaka O1 or n. Term number 2 ganjalo until you get to what? To the 6th term that they are looking for. Sharp.